engaged in research and detailed analysis of the existing solution in the field of development of battery management part of the battery-powered embedded devices. Our initial research has been done in order to better understand hardware and software elements of BMS, but also identify relation that exists between these elements on the application of the battery embedded system. Also, one of our goals was to develop a systematic approach that would make it easier to identify only the elements of the hardware and software architecture which of the BMS which are able and which are essential to the specific battery-powered embedded application. A paper which name is a Systematic Approach for Designing Battery Management System for Embedded Application presents a framework that can be used to systematic development of BMS software hardware and software architecture. I'm sure that all of us witnessing a growing trend in the prevalence of various battery-powered embedded application. This trend is most noticeable when we talking about Internet of Things, where we faced with different battery power, smart embedded IoT sensing node, but there is also a lot of different application with exploit battery power embedded systems like electrical vehicles, unmanned aerial vehicles, different smart wearable device, and etc. These various application impose different system level requirements which are related to the design of software and hardware parts for monitoring and maintenance, but also for controlling energy flow inside of the system. What is important to notice is that battery is used as main energy source in these systems. So we can say that battery state and properties directly affect system operation and its performance. When we're talking about battery power embedded system, there is a lot of functionalities, but some of the functionalities like battery monitoring, battery maintenance, estimation of battery related parameters, control of energy flow are very important to exist when we're talking about battery-powered embedded system. These functionalities are important uh, are important for this battery-powered embedded device for extend its remaining operational time and to prolong battery lifetime. All this functionality is usually given in one special part of the battery-powered embedded devices, which is named as battery management system. Sometimes it can be given a separate system entity with dedicated hardware and software parts, and sometimes it can be given as an embedded software functionality. Whichever form we are used, it is important to mention that BMS is essential part of any battery-powered embedded system. As I already mentioned, there is a huge trend of increasing use of battery-powered embedded system. Designing of battery management part of this system is very challenging. But I want to point why this is so challenging. Because we have a various of application that lead to the conclusion that we have a various of requirements. That is the key point. And during our research, we focus to go through all possible realization of BMS. And what we notice that many BMS solution fits only the specific application needs. So where is the problem? There is no unified approach in their design. The main question which we want to answer during our work is it possible somehow to systemize the process of BMS hardware and software development? And there are also two sub-questions. Why we want to do this systematization? Because we want to find some relation between application requirements and battery management system functionalities. Also, we see that in many BMS realization, we have a lot of different parameters, but we don't know how to classify them, which parameter is important to which application. We don't even know what parameter exists at all. So after that, we start our research in order to develop systematic approach. First, we start to research all existing methods and trends. After that, we proposed top level reference hardware and software architecture of the BMS. After these two steps are done, we produce some top level reference which can be used in order to systematize process of BMS development. In order to demonstrate how this systematic approach can be used when you're designing a battery management system, we define some groups of battery power embedded application. And after that, we describe how our approach can be used in designing all BMS that exist into these four classes. Class number one represents all low power application which use the simplest hardware and software approaches. Typical representative of this application class is low power sensor node. Second class is little complex in the form in hardware and software, but what is most important, why this class is identified? This class is identified in order to demonstrate a battery power and embedded application which load profile isn't well known. And typical representative of this application class is consumer electronic devices. Class number three, hardware and software parts of this class is much higher complexity than application from class number one and two. And these devices from this class require constant monitoring to prevent hard system failures. Typical representative is unmanned aerial vehicle, and the class number four is the most complex class, which use high current, high capacity battery, and it is typical representative is electrical vehicle. Top reference hardware architecture is presented here. As we can see from this, there is three typical paths which can be notified. It is power path, sensing, and control paths, but also there is three main blocks which also can be identified, which are important when we designing battery powered battery management system. Power management block is important to manage energy flow through power paths. Analog circuitry present different analog electronic parts. It sometimes encapsulate functionality elements like transistors, switches, and stuff like that. Data processing and control is the part of the BMS which is usually given in form of microcontroller unit, where you can download your algorithms which are able to control all BMS functionality. This is some representation of our top reference architecture, which is used to describe hardware architecture of the specific application. As we can see, application from class number one had the most simple architecture. Power management is given in the form of simple switches. All control, there is no separate MCU where you can implement control. Opposite of that, we have application class number two. Application class number three may use instead of use single battery pack, can use multi-cell battery pack, and it is sometimes important to use logic which will balance energy in and out. And this is how we can describe architecture of the most complex application in the class number 4. So there is a lot of different parameters which can be noticed in any BMS. In our work, we also do a classification of all of these parameters. There are two types of parameters: battery-related parameters and system parameters. You can see how we classify them, but most important is that in our paper you can find almost every one parameter which can be found in a battery-powered embedded system. Here is proposed the top reference architecture of the software, and as you can see, 6 blocks are identified as a part of the software. And on this picture, you can see how we use this proposed software reference architecture model to describe software of particular devices from particular application class. in the end, I want just to point out some most important conclusion that we are successfully done during our research. So as I already mentioned, the goal was to create systematic approach that will easily development of battery monitoring systems. So in order to support that, we identify basic functionalities of BMS, we establish relation between application requirements and system functionality, give overview of all system parameters and battery parameters, and also give their classification. We propose framework that can be used when creating software and hardware architecture of any BMS based only on application requirements. Introduce architecture elements, sustain systematic approach and maintenance, as well as building power aware and energy aware embedded application. Uh, Design and implementation of particular architecture elements is seen as part of future work. So that was a little presentation of our work results which we done. So I just want to thank you for your attention and sorry for maybe too long presentation. Sorry.
It's okay. Thank you. Very nice and concise
Mhm.
presentation. I would like to ask now, do we have any questions?
I have a simple question. As we were talking about this BMS, battery management system, so can we just implement or incorporate this BMS for solar power management systems also?
Uh, yes, this approach can be used. For example, I don't have time to go in detail, but this approach can be used also to describe architecture of BMS used in solar powered system.
Okay, okay,
It is
that is fine.
include in application class number 4, which present all application which use some form of energy harvesting.
Yes, yes, that was the particular exact point where I was leading. So we were working sometimes before some solar energy harvester kind of things. So
Mhm.
I would be interested to know where we can use this BMS for the energy harvesting thing with solar.
Yes, it will be my pleasure to use some of this research in your work because I'm pretty sure that this approach, systematic approach, will help you when developing particular BMS functionalities.
Okay, sure. I'll send my mail ID over the chat, so you can share your documents if you have any. Thank you so much.
Thank you.
Okay. Thanks a lot for a good presentation.